Okay, this video is just explaining how to find the tangent line at a specific point given a function. So what we're looking for is a line that is tangent to this function at this specific point x equals -2. So I'm going to draw out roughly what this looks like to the left. We have x squared plus 3, which is going to look something like this. Okay. And I'm at x equals -2, so I'm going to go -2, and I'm going to go up to this specific point. And so I'm looking for the line tangent. Remember, that means it just touches it one time right here. This is the tangent line. Okay. You can read that. That says tangent. Okay. So this is, I know this is -2. Okay. And some y variable here. Okay. Some y value. So to find an equation of this line, I know that the equation of a line is y equals mx plus b, right? So I need to find my m and my b. Okay. So the m is slope, right? So I'm going to write down what I need over here. My m is the slope. I need that. I also need to find my b, but I also need to find b. I need to have a pair of coordinates. So I already have a coordinate here, -2. I'm going to call this x1 just to show that it's a specific coordinate, and then I need a y1, right? So my two final destinations are M and B, but I need X1 and Y1 to find B. Okay. So let's start by filling these in. I know that my X value is -2. So this is -2 right here. Now let's find my Y value. To find my Y value, I'm going to find F of -2. So I'm plugging in -2 into the equation, and that will get me 7. So my Y value is 7. Okay. So this, when I plug in -2 into the equation, I get my output y, which is 7. Good. Now I need my m. M is the next thing I need. So to find m, my original equation, I'm going to use a new sheet of paper here for space. My original equation was f of x equals x squared plus 3. Okay. The derivative of f of x through power rule is 2x, because I'm bringing that 2 down, subtract 1 from it, I get 2x. Okay. But I don't want, this is the slope for all values, but I want it specifically in the question, specifically at -2. So what I'm doing is I'm plugging -2 into this to get -4. Okay. So that means the slope of this line right here, the rise over run of this line is -4. Okay. So m equals -4. So one more time. I took my function, I took the derivative of the function that gives me the slope at all points, and then I plugged in -2 into that, and I got -4. Okay. Back here, m equals -4, b equals something, x1 equals something, and y1 equals something. We need b. Okay. To find b, now that I have a pair of coordinates in my m, I can plug it into this formula. So I can say that 7, my y, equals -4 times -2 plus b. Remember, I'm solving for b. So this becomes 7 equals 8 plus b minus 8 minus 8, -1 equals b. Okay, so now I have -1. So now that I have my b and my m, I can plug these values into my slope function, and I'll get my equation of the line. So when I plug in m, I'm going to get y equals -4x minus 1. And that is my answer. That is the equation of the tangent line. So just to recap, the steps are write down the equation that you're looking for. Note that you're looking for both the slope and the y-intercept. And you need a pair of coordinates to find the y-intercept, the b. So find you're given an x. You're gonna put that here. You're gonna plug it in to get the y, and then you're gonna use both of these and the slope, which you find by taking the derivative and plugging in that x value. Once you get m, x, and y, you plug them into the equation to solve for b. And then once you have b, you substitute these back in to find the equation. And these are the steps.